Hi, welcome. I'm Old Doc Charles, and this is Railway Infrastructure Systems. This is part two, where I'm going to talk about route selection. This is all the crap I'm going to talk about. It's all very wordy, this one. You'll have to bear with me with all the words, because there's lots of words. How do we know where to build a railway? And what type of railway are we going to build? Well, there are people who sit in offices analyzing where other people live and where they want to go. And this demand analysis shows that building a railway between A and B will be beneficial. And depending on the distance from A to B and what lies between them, that will determine the type of railway that's needed. High-speed railway between major cities, regional railway linking smaller cities with major ones, commuter railways linking suburbs to cities, metros to move people across a major city, tramways to move people in cities where there's not enough demand for a metro, and freight railways to move stuff from where it is to where it needs to be. Route selection and alignment design, they're related but not the same, and I'll cover alignment design in a future video. Route selection is a long and complicated process with many considerations to determine the optimal horizontal alignment and vertical alignment. And you have to satisfy the stakeholders, or at least as many as possible. Now, you can't just go out and build a railway. You need to go cap in hand to the government, and they will assess your routes based on 5 criteria. The environment. You need to protect the environment and improve health by investing in public transport and other types of efficient and sustainable transport which minimize emissions and the consumption of resources and energy. The economy. Promote economic growth by building, enhancing, managing, and maintaining transport services, infrastructure, and networks to maximize their efficiency. Safety. We need to improve the safety of journeys by enhancing the personal safety of pedestrians, drivers, passengers, and staff. Integration. We need to improve integration by making journey planning and ticketing easier and working to ensure smooth connection between different forms of transport. And accessibility. Promote social inclusion by including remote and disadvantaged communities and increasing the accessibility of the transport network for those persons of reduced mobility. Usually, a number of options are investigated when building a railway. So, for some examples, 4 for HS1, when they built that in the kind of the late 90s. They looked at 8 different options for the Jubilee Line extension around Westminster. When they built the Elizabeth Line, they looked at 5 different routing options. Several hundred when they planned HS2. Of course, this includes not only the routes, but also depots and stations. Now I'm going to talk about the different considerations that have to be made when selecting a route. Considerations such as geographic features. That's things like hills and valleys and mountains and the like. Rivers and streams, including their floodplains. If the ground is soft or swampy. Up and down hill requires consideration of traction power and braking characteristics. So on railways, gradients are quite shallow. 1 in 45 is considered steep. Adhesion-independent traction doesn't really count. That's things like rack railways, funiculars, etc. The fact that railways need shallow gradients is a significant issue in determining the use of features such as cuttings, embankments, bridges, tunnels, and I'll talk about these in future videos. Gradients are so important that railways produce quite detailed gradient maps and put up signs wherever the gradient changes. Another consideration is the underlying geology, different layers of rock, clay, sand, gravel, and all that sort of crap. It affects the tunneling. how deep you tunnel, the direction you tunnel in, and the tunneling method that you use. It also affects the surface track, the surface performance, durability, the stability of the track. Another thing you have to consider is the existing infrastructure. So on surface railways, you've got buildings and historic ruins and things like that. You've got other railways, roads and canals, etc. For underground railways, building foundations and piles, other tunnels, which have various functions, sewers and other buried services, etc. In cities, it can be difficult to thread a route. You've got all these tunnels you have to avoid, but you want to be near some of them because you might want to build interchange stations. You have to consider utilities, sewer pipes, gas mains, water supplies, electricity cables, communication cables lay buried in the ground. They're not always correctly marked on the map. Some things, if you want to cross over them, there's strict regulations. Electric railways can cause corrosion of metal pipes. Overhead power lines are always a hazard. You have to consider the vehicle characteristics. Vehicles with minimum radius requirements, many vehicles as low as 50 meters radius, but this is at restricted speed. The minimum radius on London Underground is 61 meters. That's on the central line at White City. High-speed operations require large radii, sort of 1,000 meters minimum radius. Heavy haul freight operations require minimum gradients, no more than 1% or 1 in 100. You have to consider the passengers. Comfort is now a significant factor in modal choice. Passengers don't like to be thrown around. You have to limit acceleration from stop to stop. You have to limit the lateral accelerations. You have to limit the vertical accelerations. You have to limit the jerk in all directions. There are political considerations. Politicians may lobby to have a route built through the middle of their town so they can have a station and put it on the map. NIMBYs will form pressure groups to block a route being built because they don't like the smell or whatever. You have to consider land contamination. The land may be contaminated by any number of toxic chemicals carelessly discarded before anybody cared about the environment. If you're using an old railway alignment, you need to consider the contamination from previous traffic, whatever the line carried. All this stuff is very expensive to clear up. Archaeologists may want to dig your cutting with a trowel and dustpan. There are environmental issues to consider. Environmentalists will not take kindly to anyone wanting to build a railway through a patch of rare moss or bulldoze a newt. Rare snakes and other creatures can be captured and, relocated. Some people just don't like the railway to spoil the view. You have to have an environmental impact assessment. That's an EIA, and that will help you identify problem areas and is really something you have to do before you can get permission from the government to build a railway. A thorough EIA is very expensive, but it can save money in the long run. So when we have talk about environmental impacts, first of all, you've got the impact, which here you can see there's some, poop leaking out of a sewer pipe. And that leaks into the river, which is effectively a pathway. So the poop floats downstream. You then have a resource, which is contaminated by the impact. The resource is then consumed by a receptor, and then there is the effect of that consumption. Railways can be noisy. There's airborne noise, sort of rolling noise above about 30 kilometers per hour, equipment noise, beeping doors, announcements, whistles, and screaming fans in stations. You've got what they call ground-borne noise. That's vibration, generally at low frequencies, propagates from the track bed and through tunnel walls. There's community severance. Got a limited number of places where you can cross the railway, can cut community links. Farmers, they require access to distant fields, can lead to trespassing and other social issues. So in the UK, you have to get what's called the Transports and Work Act. 1992 order is a legal planning process to enable the promoter of a scheme to gain the legal authority to build it. Under the TWA, an application is made to the TWA Orders Unit, and it's part of the Department for Transport. You need to submit a full proposal, draft order, a statement of the aims, a summary of all the consultations that you've had with all the people, the stakeholders, plans and cross-sections of where you want the route to go, the environmental impact assessment, the names of the owners of any land that you're going to compulsory purchase, how much all this is going to cost, and where you're going to get the money from. If the government are happy with all of that, they will then grant you permission. That's basically it. This is all the crap I've kind of talked about. It's traditional to include a recap, and there is. Yeah, I think that's all. Next time, I think I'll talk about alignment design. Yeah, I think that need be all.
Trong này hậu tắc tắc anh nè. Ây da.